All right, welcome to physical science. We are going to change gears completely and we are going to start focusing on the physical science aspects. So everything that we've learned in chemistry, we've kind of come to a close. Now we're going to start talking about physical science. And remember what encompasses physical science. We're going to talk about motion. So we're going to talk about velocity, acceleration, distance. We're going to talk about forces, all right, momentum. What else will we talk about? Electricity and magnetism, density, all these things that kind of encompass physical science to give you a little preview of kind of physics and what physics could be about. So, where do we start that? We are starting with chapter 11. So yeah, we've jumped a few chapters, but you can ignore that. And it's chapter 11, and we are starting with motion. Now, when we start talking about motion, we have to talk about simply two terms for section 1. Distance and displacement. What is the difference between the two, distance and displacement? Well, anytime we're talking about distance and displacement, it really depends on your frame of reference. Everything's going to look like it traveled differently according everything's going to look like it traveled differently according to where you're standing. All right, think about like a basketball official. All right, he gets a lot of grief because the fans see everything from different viewpoints than what the official does. That's the same thing for distance and displacement. Everything's going to look slightly different from the angle that you're viewing it and how far away you are viewing it. So that's distance and displacement is kind of the same thing. So we need to make sure that we have a good frame of reference which allows us to see the motion clearly. So, distance. How do we measure distance? What's a good unit for measuring distance in? Let's say I'm measuring, we talked about this earlier in the year, I'm measuring the distance of my foot. All right. In the metric system, what's a good unit to measure my foot, the length of my foot in? Centimeters. I would accept that. How about if we're talking about the distance from here to Dodge Center, what would be a good unit to measure that in? Kilometers, right? How about if we're talking about how tall LeBron James is? Meters. So measuring distance, distance is the length between 2 points. It's a straight length. So how far is here in Dodge Center? All right, think about it there. So distance is it taken when an object moves in a straight line between 2 points. All right. Distance is pretty self-explanatory. Displacement, however, is defined as the difference between your starting point and your ending point. And displacement can be used for directions. So, let's look at an example here of displacement. Displacement is the distance between your starting point and your ending point. So, let's say we are on Highway 56. We have Brownsdale, Hayfield, and Dodge Center. All right. Now we know it's 15 miles from Brownsdale to Hayfield, and it's 10 miles from Hayfield to Dodge Center. So let's say one day we are driving in a car and for some reason we have to go to Dodge Center. So I traveled here to Hayfield, to Dodge Center, and let's say we traveled back to Hayfield. We're going to ask two questions in this example. What is the total distance you traveled? Well, we know this arrow was 15. We know this one is 10, and we know on our return voyage it's 10. So 15 plus 10 plus 10 is 35 miles. That was the total distance traveled. However, your displacement is the distance between your starting point and your ending point. So in this example, where did you start? You started in Brownsdale. Where'd you end up? Hayfield. What's the distance between these two? 15. So even though your distance was 35 miles, your displacement is going to be 15. That is the distance between your starting point and your ending point. So that is displacement. Now we can use displacement for directions as well, and we'll talk about that in a second. So think about it this way. A physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. What's their total distance traveled? 4, 6, 10, 12 was our distance. What's our total displacement? Where was our starting point? Where was our ending point? Same spot. So our displacement is 0. So the difference between distance and displacement. So just kind of something to think about. Displacement is the distance between your starting point and your ending point. Distance is the overall distance you've traveled. All right. Now, what if they occur at an angle? All right, that's kind of our next question. What if it occurs at an angle? Well, what we're going to do is a vector. We're going to talk about vectors just a little bit, but a vector is anything that has magnitude and direction. So when you give displacement, it has to have a distance, like in meters, and a direction. So just something to think about. Now, what if it's not a straight path? So total distance travel, let's say I'm starting here. I went 1 block, 2 blocks, 3, 4 blocks, 5, 6, 7. That was my distance traveled. My displacement would be figuring out this line in red. All right? So my displacement would be figuring out this line in red, the distance from my starting point to my ending point, which we'll talk about how to kind of solve in the upcoming chapters. But if it's not a straight line, you can calculate it at an angle. So remember, displacement, when you figure out displacement, you need to figure out not only the units, meters, centimeters, but you also need a direction. So a lot of times, direction is a key when we're talking about physics. Some units need direction, some don't. And that's what we're going to distinguish. So, distance and displacement. Remember the difference. Distance is the overall distance traveled, or the overall amount traveled, overall length traveled. And displacement is the distance between your starting point and your ending point. This is Mr. Clennard signing off.